Section 6.2 talks about logarithmic functions. In this section, it's very important that we separate between a log form and exponential form. A function f of x equal log base b of x is called a logarithmic function with base b. If b is a positive number, that b right there, and not equal to 1, that reminds us with an exponential function. Then y equal log base b of x means that x equal b to the y. Now, to start off, I normally put the properties after, but to save you time, this definition turns out to be the most important for when we get to solving applications in 6.4 and 6.5, or solving equations. So, I want to get a few properties out of the way. First property I want to show, if you have a log, and the base of the log, this is called the argument, log of a quantity. Kind of like here when you say log of x. If you take that base, or the argument, whatever the argument is, if it matches the base, they undo each other, you're left with a power. This is really more like it. So I would really focus on property 1, property 2, and property 3. And here, if I'm taking the log of an exponential, so I have a log function, and the argument, whatever you take in the log of, happen to be an exponential. If the base of the exponential match the base of the log, they undo each other, you're left with the power. If I'm taking an exponential function, this is an exponential, this is a number raised to a power. If the power happen to be a log with the same base as the exponential, they undo each other, and you're left with x. I'll talk about this in a minute. For now, let's just stick with this. 3 properties I need to get. So one of them first one says, if you take the log of any base as long as its base is positive and not equal to 1, of 1 that's always 0. Second one says, if you take a log of a base, and whatever you take in the log of happen to be an exponential, if the bases match, they undo each other. And if you're looking at an exponential function in which the base is b, and the exponent, the power happen to be a log, in which the base of the log and the base of the exponential match, they undo each other as well. Now, the reason I'm going over this, I would really like you to solve equations not by memorizing the definition, by using some common sense method. And let me show you what it is. If I want to go from this form to this form, if I see exponentials and I want to go to log form, I will log both sides. If I have logs and I want to go to exponentials, I'll make each side a power. For example, when I look at problem number 10 on page 397, it says, write the exponential function equation in logarithmic form. So they want us to write this as a log. Since this is an exponential, what I'm going to do to eliminate the exponential, I'm going to log both sides. Can you do that? Yeah, you can. What base should I use to make use of property 2? I could choose the base of the log to be whatever I want. What base should I use so that that's satisfied and the log disappears and I'm left with just that quantity? Shouldn't I use 6? And if I do that, wouldn't those undo each other and you're left with -2 equaling log base 6 of 1 over 36? You don't have to simplify. It doesn't even need to make sense. You just need to find it. Nothing more. Oops. So let's look at the next problem, problem number 12. If I want to transform this, and I notice this is an exponential, I have a number raised to a power, I'm going to log both sides. No big secret. What base should I use so that this exponential cancels? I need the same base as the exponential. If I make that an 8, those undo each other, I'm left with 2/3. And here I will get log base 8 of 4. Much better. Doesn't look as pretty, but I can fit an actual, oops, wrong coloring. There we go. Good. That will work. And if I take number 16 and stretch it out a bit, again, I want to get rid of the exponential. Since it's an exponential, I'm going to log both sides. What base should I use? To make use of property 2, I'm going to look at the base of the exponential and match it. You're allowed to log both sides with the same base. You can't say, I'm going to take this with a 2 and maybe put a 3 there. They have to be the same. That's allowed. Those undo each other, and I let -9 equal log base 2 of 1 divided by 512. So this first homework assignment is getting used to going forward and backward, and that's a lot more important than you think. If I look at number 20, this same deal, I'm going to stretch that out a bit. So on number 20, what I'm going to do, I'm going to log both sides. I'm allowed to do that. What base should I use to eliminate the exponential? This is the exponential. I look at the base and I say, well, make it 81. Whatever this base is, this base is. Those undo each other. And I have a log instead of an exponential. By the way, a student showed me this trick. I should do it differently. Here, I want to eliminate the exponential. Here's the base of the exponential. I'm going to log both sides. Logs and exponentials are inverses. So to undo an exponential, you need the log. I need to match the base. That base is 8/9, and that base is 8/9. Those undo each other, and I'm left with a -3 equaling log base 8/9 of whatever this is. 729 divided, I don't like that too, divided by 512. Now I want to go backwards. The next set of problems states, well, write the logarithmic equation in exponential. So I'm doing what I did over there, and let me show you really quick. If you tell me that a equals 3, just saying, if I want to write this in log form, I could log both sides. So just to make sure you're clear on this. If I want to write this, I could log both sides. And I could choose the same base. Those will undo each other, you're left with the power. That's true in that case. Or something we haven't even considered yet. I could make each side a power. I could say, you know what? I'm going to make this the power and this the power. That's allowed. I could say 7 to the a equals 7 to the third. That's allowed as long as the base is a number bigger than 0, not equal to 1. So here, when I look at this, I'm thinking of this piece, the third property. If I have an exponential and the power happen to be a log in which the base of the log and the base of the exponential match, they undo each other. So when I see a log, this is what I'm thinking. I'm going to make this the power. And I'm going to make this a power. To what? To any number that's bigger than 0 not equal to 1. Can I do that? Yes, I can do that. What base should I use so that I will make use of the third property? I have to match the base of the log. Those who will undo each other, I'm left with an 8, and that will be 1/2 to the negative 3. I have just eliminated a log equation and transformed it into exponential. If I have a log equation right there on number 26, I look at the base. That's always what I do, whether I'm looking at forward or backward. Meaning, when I'm looking at those, I'm looking at the base of the exponential every time. When I look at a log, given a log, I look at the base of the log. I'm gonna make this a power and this a power. What base should I use so that the log with base of 81 will clear out? Well, I have to match it. And here, I have to use the same base. You're allowed to do that. If you make those the power of the same base, here those undo each other. And here I'm left with 81 to the negative 1/4. Number 30 is next. The same deal. I start with the base. What is the base? There it is. So I already know what I'm going to do. I'm going to take 14 and I'm going to make this side a power. You could make the whole side, not the pieces. Be careful. I'll tell you what that means in a minute. And whatever you make to the left, you must do to the right. Those undo each other. 1/196 equals 14 to the negative 2. Let me just warn you. If I have a equal 1 plus 3, you can't say 5 to the a equal 5 to the 1 plus 5 to the 3. That's not allowed. You could say 5 to the a equal 5 to the 1 plus 3. Yes, as long as you make this entire side a power, that's allowed. And 3 more to go. I want to eliminate this log, so I'm gonna look at the base. The base is 13, so I know how this game's played. I'm gonna make this the power of an exponential with a base of 13. The right side is simple. The left side, log base 13 of 2197, and those undo each other by the third property of log. Right there, in case you missed it. If you have an exponential, base b, and the log happen to have the same base, they undo each other because they're inverses. So you're left with 2197 equaling 13 to the third. (34) is the same type. I see a log on the other side. It doesn't matter. What's the base of the log? The base of the log is a 6. So I know how this is going to play. I'm going to make this a power of an exponential with a base of 6, as long as I make this a power of a base of exponential, an exponential with a base of 6. Now what does that equal? That's next class. Those undo each other, and I'm left with 6 to the negative 4 equaling 1 divided by 1296. And the same deal with the last problem. I glance, okay, I clicked that button by mistake. I give away what we're going to do next time. I look at the base of the log. The base of the log is right there. So I know how this is going to play. I'm going to make this a power as long as I make this a power to the same base. I could choose a 5, that will work. I could choose a 7. But to eliminate the log, I'm going to choose the same base, which is 7/5. And 7/5 to the 4th is going to equal, those will undo each other, 2401 divided by 625. This homework is among the most important for this chapter. Your homework is page 6.2, page 397. You're going to do numbers 9 through 35 every other hour.